Cisco Certified Network Associate 2025 Guide Day 2. This is JJ, your lecturer for the entire series. Okay. I'm really sorry about my voice. I literally just woke up right now just to record this video. I will be busy for the whole week, but I still would like to have an update to our entire or for this series. Okay. Now let's start. On the last video, we have discussed the network fundamentals and the OSI model, why it's important. So we explain the process between a computer, so this is a computer, going to the internet, right? So we explain it using OSI model. So we say we explain that, okay, on a computer you're going to connect to your router, and that on that router the ISP will provide you the IP address that will connect you to the internet, and then that internet is basically connected to all public data centers, and most likely you'll be connected to a certain data center in Facebook. Now, last time, a reason like when we ping facebook.com, let's say facebook.com. So last time, I'm not sure what would be the IP address used on that data center, but if it will be different, that means that facebook.com, or you're accessing facebook.com on a different location, because we all know that Facebook is a huge application, right? So it cater not just someone in your country. So Facebook might have different data center located to different places in the world. So if you're like me, you're close to Manila, you're most likely be connected to the closest data center here in the Philippines. That would be probably Singapore. So I might be connecting to Singapore data center, like this one, when I'm connecting to cloud. Basically, we just would like to give you guys, okay, why we are changing IP address for Facebook, why we are getting different location when we are accessing Facebook. That basically means that they are hosted, or they are deployed on different data centers, so many data centers, and then depending on the configuration, like the policies, how they're going to route the traffic, how they're going to manage the traffic, that will let you assign to, okay, maybe this data center in Singapore is not so congested, so they're going to route you over. So there's this like certain computation, like load balance on it, on how you're going to route for a specific place. It's also, there could also be a reason sometimes that maybe you're not going to connecting to Singapore, maybe you're going to connect to the far places if this is down, or if this is fully utilized. Now, why I mentioned that is because later on we're going to explain a different type of topology in Cisco. So we might be discussing which part of this would be responsible for the policy, for controlling the traffic, before we do the actual configuration as we go along with the series. So that's the OSI model. And we also explain, if you guys still remember, I've always highlight that OSI model, it's more on the theory side. Okay, theory. So why is that theory? Because if you're going to even like look the configurations of your devices, you're not going to see any OSI there. You're not going to see any OSI. It's basically because it's a reference model. It's a framework on how this connectivity connects to Facebook. Right? Usually, it's an introduction for people who just started their networking journey, or just to get an idea on what networking is. So that's um, what OSI is used for. Now, on this series, or on this today's episode, we're going to discuss what is TCP over IP model, like this one, and it's uh, why it's being regarded as more on the practical side compared to OSI. Okay, we're going to discuss that, but let me give you a quick history about the industry that we're in right now. So before, just to give you a little background about uh, these framework is about, or why do we have like certain framework or reference model, because reference model or framework, it's basically a set of rules, instructions on how should a device communicate to each other, right? So before, we have these big companies, even until now. I'm not sure with digital equipment, but these are the two main companies before that manufacture hardwares, computers, or networking gears. So we have IBM and Digital Equipment. So they are the leading brands way back. I think around 1960s, 70s. I'm not very sure about the date, but they are the leading brands that manufacture those devices. And before, if you have like a, let's say, a monitor in IBM, all of your equipment like CPU, mouse, keyboard, all other stuff should always be IBM. So if you buy one part of IBM, all of your equipment should now use IBM. If you buy a piece of hardware to digital equipment, all of your equipments should now use digital equipment. So it means that you cannot uh, build your computer like what we're doing right now, that we have a different brand for monitor, for processor, for keyboards, for mouse. Before, um, if you buy a certain brand, that's the only brand that you can use. Why? Because they basically cannot talk to each other. They do have a set of rules on how would they connect to you, right, or to a device. Now, that's a reason. That's also the reason why, okay, those companies decided, let's stop this nonsense and create singular, or like a framework, a reference model. So we have a lot of reference model, including the OSI, but we ended up with TCP over IP model. So this will be the industry standard, and this is what we are using right now. And it's also the reason why your computers are able to connect to different brands, regardless if they do have different design, because the way we communicate uh, is followed to this model, TCP over IP model. So it's a protocol suite itself, and that's also one reason why um, we consider OSI as a theoretical, while TCP over IP model is practical, because it's being used by your computer. Like if you're going to go to Windows R, so ncpa.cpl, so this is a shortcut for network settings. So even if you're going to look at your network connections, like the settings, let me hover to my Wi-Fi here. I'm not going to see any OSI model right here, like a protocol use for OSI. But if you're going to look at the TCP over IP model, here we go. You're going to see that we're using the TCP over IP for the network connectivity. Look at that, TCP over IP model. So basically, it's a protocol suite. It's something that we use even until now. Now, why OSI is still relevant until today, because OSI, it's basically it's a more detailed version of TCP over IP model. So this physical layer, this could also be called as network access. So don't be confused. There are just different terms on it, but they basically represent the same part of the layer. So this could also be called as a network address, and sometimes they call it internet. That's why it's a TCP over IP. IP would be like internet protocol. So this part of the layer could also be called like internet, but this one is fine. It basically represents the same thing. Now, reason why OSI is still relevant even until today, because if you're going to compare those two models, they just basically the same, and they represent and they just have a more detailed representation. Look at the OSI. We have the presentation, and we have the let me change we have the presentation, and we have the session layer. But in the TCP over IP, it's just the application itself. And if you're going to review what we have discussed on the previous video, when we mentioned that presentation, it's more on the encryption. So this is the encryption side, and the session is just responsible for making sure that the connectivity is up, or the like the session, the socket, this is where the socket is, like making sure that the session is up or closed, or just basically make sure that if it's being used, it's still up, or if not, the session should be closed. So unlike with other layers on this one, application layer, you have a visibility on this. So this is the HTTPS. This is what you type on your browser. So most of the time you have idea what the application part is, because this is what you type in the browser. But on the presentation, it's the encryption, and this one is the socket. We're in just making sure that the session would be up or not. So you don't have any visibility on this one, because on the background, if you've run HTTPS, there are always encryptions already wrapped with it. So you don't have any control over it. You're not going to have any visibility about what that is. So the TCP over IP model, okay, it's just basically the same. That's why they just combine all those in the application layer. So this one is more detailed, but the thing is, you cannot see the encryption, but it's happening on the background. You can see the socket, but it's happening on the background. That's why on the TCP over IP model, it just grouped into one part. Now the transport layer, this is where UDP is and TCP. So quick heads up. So again, UDP, it's a way to transport if you just want to make sure that the connectivity will be really fast. TCP, you're making sure that the receiver will receive all the data that you're sending it to. Again, you're going to use the UDP most of the time. It's a voice, if it's a live stream, wherein your main goal is just to make sure that to send the data as fast as possible. Now, I mentioned that okay, you don't have any visibility on encryption, but how about transport? Are you able to see this one? Though this is not exposed to user a lot, but you can go to your command prompt, and here you can type netstat. So it will basically show all the connection happening to your computer and all. So this is more on the private address itself, but you're going to see what protocols are being used. So if you, like, let's say you browse or watch a YouTube video while typing the netstat, you'll see that you're connecting it to YouTube, and also you're going to see what kind of protocol is being used. But at least we have a visibility about the connection itself, unlike the presentation part. So that's how you're going to see it on real setup. If you would like to to monitor all the packets going in, network address, it's still the same. it's the IP address. So if you're going to Windows RN CPA.cpl, go to your Wi-Fi and go to the properties. This is where you usually configure your IP address. So right now it's obtained automatically. So I'm getting an IP to the router itself. But if you would like to assign your own IP, this is where you put it. And in a corporate setup, most of the time, if it's a server, you're going to be the one who's going to define it. And if it's a user, there will be a certain pool, like a dynamic IP, that will be assigned to them. And also, if you're going to compare it, the physical, they just put the data link and physical layer into one, because we all know that every physical device, there should always be a MAC address on it. So like you cannot separate those things. So this is the TCP/IP model. It's a real framework. It's a protocol suite that we're using right now. We consider it's more on practical side, but nonetheless, OSI is still very relevant even until today, because it's a just more detailed explanation of what a TCP over IP model. Okay, so enough with the reference model. Let's go with the some of the topics with let's continue the topics that we have where we left on Cisco. So I'm going to explain this more on the overview itself of all the topics. So we're down into 2 and 3 tier. So a 3 tier network setup according to Cisco. So this is like a design recommended by them. Even until now, this is being used by enterprise company. So let's say you have a computer and it's connected to a switch. We all know it's a switch if it has like multiple ports, and this will allow you connect to it will allow your computers to connect to these devices. So according to Cisco, this is the access layer. Okay, so access layer is basically like saying access to the network. How can we get how can the user access to their network? And most of the time, it's the PC connected to the switch. So it's an access layer because this is where users who are in endpoints are able to access the network itself. And on this one, on this switch, there is what we call the distribution, or I'll just put it like this. So this one is it's still a switch. It could be a router, but the point of this one, it's a distribution layer. So if you're going to go back to our previous explanation on about the policies and all, though we're not going to explain it all, but on the distribution layer, this is where all the policies, like the routing, or how are we going to manage those traffic, what are the protocol that's allowed. Like let's say your you have a business, and then you like to put restriction that it cannot access the certain team or certain part of the network. So this is where you put it on the distribution layer. So it's about policies, it's about the design of your network, what's allowed and what's not allowed on your company. So this is the access layer, and this is the distribution layer. Now if you have a different like let's say on a company you have, or in a university you have different colleges, you most likely per college or per building you have another access layer. So this will be access layer again, a switch, and then you'll have your distribution layer. So where this is or all the policies, what can be routed going to this building, what are the things that can go to this traffic, what are the things that can go to this building. So this is again the distribution layer. Then of course, we have the core router. This is like the core. The goal of the core router, it's more making sure there are not like a lot of policies and control on the core router, because they're the one who's going to uh, connect all of those buildings to their router. So they're responsible to handle, okay, what are the traffic going to building 1 that can access to building 2. So restrictions here, it's minimal. It's more focused on making sure that I can connect B1 to B2, like building 1 to building 2, building 3 to building 4 as fast as possible. So that's what the role of a core router is. And this is the 3-tier architecture. So we have the access, distribution, and core router. Now, the 2-tier, it just basically like combine the core and also the distribution layer, because most of the time, if it's a company, you don't really have a lot of buildings on it, or it's not really as big. Enterprise could be big, but it's connected to a different site, not just a single building. This is only that, like the 3-tier. When I'm looking at this architecture, this is only good if you have a lot of users on the specific location. But if it's an enterprise business, and then you have to have a lot of users different site, this is not the ideal for it. So that's why 2-tier, it's also called a collapse model. It just basically connect core and the distribution layer. So that's a 3-tier and 2-tier. But I just would like you to highlight what are the difference between the two. So we have the access, which basically connects the how the users can connect to the network, and we have the distribution where all the policies are located, and core router is the one that is going to connect all those all those blocks to each other, and main goal is to be as fast as possible. And again, it's going to be a 2-tier if it's not as big, and they just have to connect the distribution and the core layer. Now, going to the next topology, the spine leaf. Here we have leaf switch, leaf, and then we have spine. Like this is the leaf, this is the spine, and these are the nodes, or like the endpoints. So for the like a spine leaf topology, usually it is used by a data center. So why data center? Because if you're going to look at the setup, there are multiple paths going from leaf switch 1 to like the spine switch 1 and 2. So there are multiple paths going in to the whole topology itself. Why is that? Because the spine leaf, usually it used in a big data center, and your endpoints, unlike the normal enterprise setup, the endpoints for spine leaf, these computers, this could mean these are like the server. And we explained on the previous video that the server is basically a computer that that is much more powerful in terms of the specification of the device. Why? It's because its goal, its purpose is to handle a huge amount of traffic. So reason why a spine leaf is designed like this, because it has the idea that, okay, the endpoints are servers, so most likely if you have a DNS server here and a mail server, and there are like thousands of users connecting to DNS server, so when they query on and going to this setup, they might consume a huge amount of traffic going to this one, and then this will be the link that they'll be using. So what we're trying to avoid is, once we have a mail server here and it noticed that on this link it's already fully utilized, you can use other part of the uh, leaf switch, right, to connect to the user. That's the main purpose of this one, and it's not just about redundancy, but also making sure that it will be able to handle a huge amount of traffic, assuming that this kind of setup is really good for servers, because we all know that servers, it handles a huge amount of traffic, handles different type of users. So most likely a data center, or like a cloud data center for AWS or Azure, usually that this is the kind of setup. So there are multiple paths going in and out to the endpoints, just basically because these are like already servers on this on their end. So that's the spine leaf topology, and we have one. We have a different type of one, but I'm just going to focus on the the simplest form. So one is just basically a wide area network. So you have different, let's say, you have here like India, and then you have here US. So all of it will pass through the internet to connect to the server. So India, it might be, let's say, you are outsourcing your like database team in India. So there are will be like database engineers here in India, and database engineers, they might be handling servers in US that like a database tool here that is located on the US side. So main reason why we have a one topology is to making sure that this network from India will be able to connect to the US, and that's using usually through a VPN. So it's the one topology is just making sure that it looks like they're on the same site. It means when you're in the VPN, most of the time you're connecting through a private IP. That's the main goal of VPN, and to making sure that the connection will be safe from India to the US. Or let's say you have a different site that handles customer service, especially the BPO industry. I think we have a lot of industry in the BPO. So main reason why you have a BPO industry here is because the servers used to handle like the calls or to get certain information that is here. Let's say BPO industry in the Singapore. So if you're BPO industry in the Singapore, so the users in the Singapore will connect to the US, and then of course if they handle the customer service, they will be needing access to the database of clients of those. Let's say it's a telecom. Of course, the telecom, they do have a server here that the site here needs to access. So that's the basic one topology. And then the small office, home office, Soho. When I'm looking at this one, I think it's just a simple setup of devices. So you probably have like route access layer here, access layer here, access layer, and then you just have to connect to the router, or maybe directly to the ISP itself. So just a small office. So there are no restrictions, or maybe there's a restriction, but it's not as complicated as what we have in the enterprise model, or the redundancy or the setup is just very simple. Maybe they are the kind of office that doesn't rely much on the internet to have the operations going. And on-premise and cloud, this is what's new right now, especially the changes that's happening because of cloud right here. But it's good to know what's cloud and what's on-premise, and what's the reason why we have cloud setup or cloud engineers right now. So what I always tell my students, that before cloud, or before the boom of this cloud roles right now in the IT field, all the setup is on the company itself. Like let's say I mentioned, like if you have let's say you're a banking company. But for sure, if it's a banking, it's almost impossible that you can outsource it in cloud. But I'm just going to use it an example. So if you're a banking company, you have a banking system. I'm just making it as simple as I can. Banking system, and on that banking system. So if you're in a company, all your server, this is a banking system, is located on the premise itself. So the banking system, it could run over like Linux, or it could run over Windows, but it's a banking system still. And uh, the cloud, the only difference with cloud is that this banking system, instead of have buying a server, because the main reason why we have the cloud is because in order for you to store, I always mention this, like in order for you to store a server or deploy it on like the application to a server, you need to like we have the Blade server. I'm not sure if this is like our example, what it looks like. It's like a Cisco device, but you need to have these installed on your rack or on your cabinet, wherein those banking system is deployed. So it's basically still a server. It could probably run on Linux, and it handles those application like the banking. So before this big computer here, when we say on-premise, it should have a place on the company itself. Now, with the on cloud series, you're basically renting this part on cloud. So you're connecting to their data center, and then from cloud, you're basically deploying that application to them. But it's still the same server. If it's Linux, if it's Windows, you still need to learn how to use it, and you need to connect it to a certain way. But the point is, even if you're going to go to cloud, you still need to learn Linux. You need to learn how to manage Windows Server, because the only difference with on-premise and on cloud is the way we access it. So instead of having it deployed on on-premise or on the site itself, just going to connect to a data center. If it's an Amazon, you're just going to connect to a data center, and you're basically connecting to one of their server there, wherein your application is now deployed. Okay, so that's it for our episode 2 for day 2. Thank you again for listening to our lectures. We're going to provide more updates, or our day 3 or guide 3 for CCNA topics.